This is the first and probably the last tutorial on factor theorem. Really short, easy scoring chapter, and there's nothing new in it for you. It's just one new concept. That too, it's very easy to understand, and otherwise, it's all grade 6, 7, 8 factorization. So I'm going to start off by just a little recap on what a polynomial is. Polynomial is just an expression in x. Now, it could be of degree 1, 2, 3, or 4, or so on. It could be anything. So just a small example. You would have done this under quadratic equations. I'm doing it again very quickly. This is a quadratic equation. How do we know it's quadratic? It's because the highest power, sorry, not highest degree. The highest power is 2, which means that the degree is 2. And any expression with the degree 2, a polynomial, is called a quadratic equation or quadratic expression. So now what factor theorem says is that, say you have two factors over here. Let's just call them x minus a, x minus b. These are not the same over here. The two b's I've written, the two a's I've written, they're not the same. Just assume that these are two factors, a and b are anything. So what factor theorem says is that if you take this equation here, this is f of x, by the way. F of x means it's a function in x, which means that the variable is x. Now, if you take f of a means similarly it's a function in a. So f of a means that if you replace all the x's in this equation with an a, that is a function in a. So now if this f of a gives you 0, if this gives you 0, then x minus a is a factor of f of x. So I think if I give you numbers instead of a, b, c, x, you might understand it a bit better. So say you have x squared plus 2x plus 1 equal to 0. And now you want to prove that x plus 1 is a factor of this. So let's just write x plus 1. Now, to prove that it's a factor, you need to prove that f of a is 0. Now, let's just compare these two. This is comparable to this, and this is comparable to this. Now, x plus 1 can be written in the form of x minus a. You need a minus over here, basically. So you can write it as x minus minus 1. Nothing changes, just writing it in that form. And so, in order to prove that it's a factor, we need to prove that f of a is 0. Now, a we have over here is minus 1. It's not 1, remember, because we took the minus here. It needs to be in x minus a. It needs to be in that form. Then you take a, which is minus 1, so f of minus 1 over here. And just replace all the x's in this equation with a minus 1. So let's do that. Minus 1 whole square will give you 1 plus 2x. So that means minus 2. And there's a plus 1 again. Now this equals to 2 minus 2, which is equal to 0. So you can see that x plus 1 is a factor over here. Now there's a very closely related concept. In fact, it's the same thing, just put in different words. It's called remainder theorem. So it just says a reverse thing, that if you have f of x and it gets divided by x minus a, then your remainder is 0. It is f of a. If you look back at it, it's just saying the same thing. This is f of a. You divided it by x plus 1 and you got a 0. You've proved that this is a factor, so the remainder is 0. And what is the remainder? It was f of minus 1, which means it was f of a. So if you're getting confused, there's no need to be. It's the same thing put in different words. All you need to know is that if you have a factor and it's in this form, just take f of a, which means replace the x's with a. If that result comes out to be 0, then x minus a is a factor. If it doesn't, then the remainder is whatever you get. That's all you need to know in the chapter. So I'm going to do two quick questions, or two board questions, which I've got ready over here. I'm just going to erase all this first. So that's the only concept. Otherwise, you just need to apply things like splitting the middle term and how to factorize, and you'll be fine in this chapter. So I'm just going to get the questions now. So this is the first one over here. So let's just copy this over here. Okay, show that x minus 1 is a factor of x cubed minus 7xy plus 14x minus 8. Hence, completely factorize the above expression. Straightforward question. There's nothing very complicated over here. Whenever you're asked to show that something is a factor, you just need to take x minus a, replace this expression with a, and prove that what you get is 0. So we're going to do exactly that. X minus a, compare it to x minus 1. So you can see that a is equal to 1. So let's take f of 1 in that expression we've been given here. So it's 1 cube, which is 1, minus 7x squared. X squared is 1, so minus 7, plus 14x, x is 1, so plus 14, and then a minus 8. So we've been told to prove that this is a factor. So for that, this is the remainder. Okay, this is the remainder. So if anything's a factor, it'll leave a remainder of 0. So if you just solve this, you get 1 plus 14, which is 15, minus 15. So you get 0 over here. So you prove that x minus 1 is a factor of that expression. And now this is a little tricky part. Hence, completely factorize the above expression. I don't know, I'm not sure if you guys have learned how to factorize using that long division method. I'm going to go over it quickly. So you have x cubed minus 7x squared plus 14x. It's like normal division, just uh, it's exactly the same. So we know that x minus 1 is a factor. So what we do is put x minus 1 over here. Now what you need to see first is what you need to multiply with x to get x cubed. So we know that's x squared. So we have x cubed here. And at the same time, we multiply the 1 minus 1 also by x squared. So this becomes minus x squared here. Then same like your normal division, you just like put minus over here. So this becomes a plus here. So you get minus 6x squared. And you bring the third term down, so it's 14x plus 14x. Same thing now. What do you need to multiply with x to get minus 6x squared? So it's minus 6x. And this is your quotient that is forming over here. So minus 6x squared. And then you multiply the minus 1 also by minus 6x. So you get minus 6x. Okay, so sorry, this will be a plus 6x. Yeah, so now you do a minus again. So this becomes a plus, this cuts out basically, this becomes a minus. So over here you get 8x minus 8. Now what do you need to multiply x with to get 8x? So that's always that's 8. So I'm just continuing it here, but it's clear that you're going to get 8x minus 8. So when you minus, you're going to get a remainder 0. Right, so this is your quotient. That when you multiply x minus 1 by this expression here, you get the whole expression, this long thing. So these are the other factors here basically, just to put it in simpler terms. So we need to factorize this even further so that we get, just x minus something, x plus something like that. So split the middle term, and what do you get? You're going to get, I think, x minus 2, x minus 4. Yeah, x minus 2 and x minus 4. So we've been told to factorize the above expression completely. Now we have one factor, which is x minus 1, and we've got these two. The final answer is this. So if you multiply these three, you will get this expression here. And also note that if you take all of these as x minus a and replace the a, you're going to get 0 as the remainder, because these are all factors. Now I'm going to do one last question. By the way, this is from ICSE 2007. Now the next one is from ICSE 2008. So I'm just going to get that now. Here it is. Okay, so again, I'm going to copy paste it. Okay, so it says if x minus 2 is a factor of 2x cubed minus x squared minus px by 2, find the value of p and factorize the above expression completely. Okay, this is the more important part right now, because you guys know how to do the second part. So let's write x minus 2 over here. Now we know that this is a factor of that whole long thing there, that whole expression, which means that if you write this as x minus a and you take f of a, what you'll get is 0. So from this we can say that a is equal to 2. Just compare these two. So a is equal to 2. So f of 2 needs to be equal to 0. And so we'll replace it in the equation, and accordingly we'll find the value of p such that the whole thing will equal to 0. So let's do that. 2x cubed. Now it's x is 2 over here, so you'll get 8 into 2, because x cubed is 8, and 2x cubed, minus x squared, which will be 4, minus px. So px, x is 2, so minus 2p, minus 2, and we know that the whole thing is 0. So 16 minus 4 minus 2 minus 2p equal to 0. Just solve now. So you get 10 is equal to 2p. So p is equal to 5. So p is equal to 5. So that's your first part done. Now your second part tells you to factorize it completely. Same method as the last example. I'm not going to do it again. It's the same thing really, but in this, I think you should pause it here and solve it yourself if you think you need to. But your answer will be x minus 2, which is the factor you've already been given in the question, into x plus 1, and the other factor you get is 2x plus 1. Okay, also one last thing before we move on to the next chapter. Uh, Often instead of x minus 2, you'll be given x plus 2 or something like that. So over there, as I told you before, just put in the form of x minus a. So put a minus sign there, and say this is the factor you've been given. So we can write this as x minus minus 1. So it will be minus 1, which is equal to a, and not just 1. Also, if you're given this as a factor and you want to write it like x minus a, you need to know, just remember that it's x minus a, not 2x minus a. So over here, you also need to divide the whole equation by 2, because you need to get rid of this 2 over here. So when you divide 2x plus 1 by 2, you get x plus half 1 by 2, that is. And then to this, again you add the minus sign. So a will eventually equal to minus 1 by 2. not 1 or -1 or plus half, nothing like that. It'll be -1/2. And that's it now. I think that's it. That's all there is in this chapter. And this comes very, very often in section A. So there's no way you should take this lightly, even though it is pretty small. So that's it. And we'll be back with the next chapter, which I think is matrices. So that's it for now.